Okay, so finding limits, there's going to be I think I put 14 questions on your test. So each point is worth 2, kind of one for strategy, one for answer. So I gave you 4 strategies. So here's your strategies. Sometimes you can just plug it in. Sometimes you can use algebra to eliminate the problem, usually factoring. Sometimes you might plug in a close value, or you have to use your analyzing. Okay, so here's an example of plug-in. If I have an equation like this, I can just plug in 6. So 6 squared plus 3. Okay, this one I obviously can't plug in a 6 because it's creating a divide by 0, so I can use algebra. So I'm going to keep the limit there. I'm going to do some factoring. So now I can plug in the 6 because I eliminated the problem. So if I was to plug a 6 into here, it'd be 6 plus 6, which would be 12. Okay, and graphically, what happened to that equation when you graph it? There would be a hole in the graph there. A hole in the graph, but it's getting... No, but just so you can kind of know, well, why can't I do that? But the graph is close to the height of 12, but it's a hole there. Okay, here I can't plug in the 6 because there's a divide by 0. There's nothing to factor. So now I have a different strategy, and that's the close values. So you might want to do a couple below it and a couple above it. So you always want to do on both sides of the 6 because a limit has to come from both directions. So, do I have a conclusion about approaching 6? What's going on with the height? Is there a conclusive number? This one would be going to infinity, but then this one would be going to negative infinity that way, so now it is no limit. If I wrote this differently, if the question had had this, what would the answer be? Then it would be that, right? So consider that. Okay, and then analyzing, well, there's just a bunch of stuff. So you should understand this. 1 over a really big number makes 0. 1 over a big negative number makes 0 still. It doesn't matter. Anything big on the bottom is still 0. It just changes your direction. Here you're coming at 0 from above, and here you're coming at 0 from below, but that doesn't matter. 1 over a really small positive number makes big positive. 1 over a really small negative number makes big negative, right? Big and small, always interchanging. Sometimes you have to talk about what's going on. So if the top is bigger, what happens? Then you are going to, one of the infinites, depending on positive numbers is dividing or negative numbers dividing, I don't know, whatever's going on. What if the bottom gets bigger? 0. What if there's same pace going on? There'll be, yeah, divide the coefficients. Some number, you would get to some number. Okay, so let's talk about this one. So if I put a 0 negative in for the x. So as x approaches a small negative number, okay, what does that turn into? Negative infinity, yep. Then what do you do with the negative exponents? What's the rule with negative exponents? They would have to change locations, right? Negative exponents. So I knew that became negative. And then what's negative exponents, right? That's making sense. What do you think about those numbers? What would happen with this value here? 1 over something big, big, big. It would become basically irrelevant, 0. So after all that, what would my answer be? 4/5. Okay, analyzing this one. So what do you notice right away when you see it? Same degree. So basically you're forgetting about all that stuff. It's like a drop of water in an ocean. Don't care about that stuff. Okay, so that's what you're thinking about. Dividing, what's going to go on with positives and negatives, all that kind of stuff. Bless you. Okay, then you're going to have a section with visual limits. Okay, so what if we go towards -8 from its positive side? So how do you follow the roadway? Just from the positive side. So you don't even look at that path. You head on this road from the positive side. So as I'm traveling, I get to a height of -4. As I travel towards -8 from its negative direction. So forget that. You're on this pathway. You'd be on this pathway. So then I'd be at a height of -2. This question just says -8. So with that, I have to take both roads. So if I'm traveling to both roads to -8, I didn't get to the same place. So no limit. And this one is not even a limit question. It just says what's the function specifically at -6. So when there's an x value of -6, this is an open circle, so don't look at open circles. I can look at that dot, which is a -3. Okay, so we're going to take the definition of a derivative. This is what the definition would be. So when I say do this by the definition, that's what it would mean. Okay, so we have the polynomial one. Okay, so I'm going to go, what's the limit as h approaches 0 of y2 minus y1? Right? Every time you do y2, you put the x plus h in over x2 minus x1. That's the definition. Okay, and again, you're doing this because the h is the space between 2 points, and that space we want to make 0 so that we eventually are on a tangent line. Okay, I need you to FOIL that all out, square it, times it by 4. FOIL, your x's cancel. Eventually you will GCF a h out, right? H cancel. As soon as you've canceled your h, your problem's gone. Okay, do you notice how I'm writing the limit, 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 limit? I write it until the point where I actually plug it in. So right here, I'm ready to plug in the 0 for the h. So if I plug a 0 in for that h, it makes 8x. So this is the general equation, but I might ask something about what's the slope at x of 2. So you would just say 16 now. You just go one little step further, right? That's okay? Do you remember how to check with the shortcut? So you can do this. So what is the front times the top? 8. And then go down a degree. We're correct. We got it right.
Can you use the shortcut at this time?
You can do the shortcut every time, but you have to do all this work. So, but you can use the shortcut to check for sure. But don't just do the shortcut and then be done, because you're going to get 0 points, because it'll say use the definition. Okay, number 2. So this is a radical one. So that's what y2 minus y1, that's what it looks like.
36, 30.
Your big bubble writing.
What, this?
Looking at how little of space I left here. And I really could have made this an extra page. Okay, so there's your y2 minus y1 over x2 minus x1. Now, if you forget what to do with radicals, you're hooped. What's the algebra radical strategy? Conjugates. So 18 root x plus h, opposite sign.
Do you have to do conjugate on this one?
Yep. Have to do conjugates. You know what? How about we just scratch this one question off and do it on the back side, because you're probably like out of room already. We'll do that on the, I think you have a whole blank paper, right? Okay, conjugates. Has anybody already done this? 18 times 18? Did we do it? 324, yep. 324. Root times a root. Then the root cancels. What do I get to do special on my FOIL? No OI, don't do them. So that was the first. Last is subtract 18 times 18 again, so 324. There's a root x, So just forget the root. Okay, so don't forget on the bottom, where did I get the h from? It's just because this x minus x was gone, so that was just h. And then I just rewrite that. Okay, so here, this 324x and this 324x would go away.
Wait, so you added 324x?
That was the distribution, there was the 324x. And then there was a minus 324x there.
Oh, so there's a 324 each.
Right there, the distribution was 324,
Oh, okay, I see.
right? Do you see the distribution? I just did it on top there. 324x plus 324h. Okay, remember every time you've canceled that h in the bottom, you're ready to do the plug-in. So if I cover up this h, you get the bottom would be 36 root x's. Right? 18 root x plus 18 root x. I'm going to check my answer because this is a test. I'm going to see, did I do it right? So 18 root x was the start. So really that is the same, right? A root x is a half. So what's front times top? 9. 1 lower. Does that match that? Yeah. Half is the radical. The negative means it's on the bottom, right? Okay, so is your whole backside open?
I just did that one from the back.
Well, now you have a white paper. There's just a blank, right?
Oh, in the very back.
Yeah, on your back blank page, let's do this one so you have more room. I'm gonna have to revamp this for next time. More room? You good with this one? So let's go. The limit is h approaches 0. y2 minus y1.
So for a fraction there.
Right, do you see the y2?
Yeah, okay.
Over x2 minus x1. Okay, so algebra, I'm putting the two fractions together here. So I need a common denominator. Okay, so I'm going to use x plus h and x. So this one's going to have to get timesed by x. This one's going to have to get timesed by x plus h. And I'm going to do that distribution on it. I'm going to times it by x plus h, so minus 24x minus 24h. I feel like on this one it's very easy to forget about this common denominator and then this denominator. Like there's two denominators. It seems really weird. Okay, so here's something I'm going to do. Get rid of those x's. So I'm just going to go minus 24h over that bottom. And then instead of dividing by h, I'm going to write times flip. Okay, so think about math. This could be something like divide by 2. I can change it to multiply by a half. Same math, right? So now what happens? Cancel our problem. There we go, canceled our problem. So what does that mean? We can plug in. So now, if there was no h right there, the bottom would be x squared. Let's check. This is what you do on your test to check. So if this is my equation, how would I actually rewrite that? So this is just a rewrite. What is front times top? Negative 24. Down a degree. What's this down? Does that match our answer that we got? Yep. You think so? Move the squared to the bottom and it does, yeah. Okay, so on your test, be ready to do any of those 3 styles. Do I need to do one where I would say, figure out the derivative of this using close numbers? Would you know what to do?
Are you gonna do that on the test?
Uh-huh.
Probably.
Like if I said, find slope at x equals 4, okay? And you did this, what's your answer? Just plug in the 4. So at 4, your slope is negative 24 over 16, which is negative 1.5. Okay, but what if I said, instead of using the definition, use close numbers? What would you do? Plug in close numbers to 4. So you would go 0.1, I could go 3.9 comma, and 0.2 I could do 4.1, or I could go even closer probably. So what is 24 divided by 3.99? 6.015. 5.985. So this is just using close numbers. Same kind of idea, right? You're doing y1, y2. So what is y2 minus y1? Over x2 minus x1. It should come close to negative 1.5, right? Should be close to that, because we just figured that out. We knew exactly at 4 the slope was negative 1.5. So does that come close?
So it's x2 minus.
This is y2 minus y1 over x2 minus x1. Do you follow it?
Formula or no?
y2 minus y1 over
Yeah.
x2 minus y1? I don't think I give it to you. If you really need it, I can give it to you, but
Yeah.
Yep.
does it negative 1.5? Boom, we kind of match, right? We just used a different process. So I might throw that at you, something like that. Okay. Okay, and then the very last part is projectile velocity stuff. Okay, so figure out the velocity from 2 to 4 seconds. Okay, so you're going to want to get a y value. So what is the y value for 2? What is the y value for 4? Okay, so how do I find velocity? y2 minus y1 over x2 minus x1. I probably should have had some units. Let's just say I wrote meters in there, so it's meters per second. Okay, the word estimate, when I use the word estimate, I'm just going to use the process of close points. That's what the word estimate means, use close points. So if you want to be close to 3, I'm going to use 2.99 and I'm going to use 3.01. That's what I'm going to do, because this is an estimate. Okay, so on a test, I probably wouldn't give you the directions, use close points to do this. I would just say estimate. So you should know what estimate means, close points. Okay, on the test, if I say find actual exact velocity, what are you doing? You're doing a derivative. Okay, you've got the words, estimate, close points, actual, get that derivative. Okay, so h prime equals, use the shortcut. What is this times the top? -8. If you go lower by a t, it's just a t. 80 times the top, there's a 1 up there, right? So plus 80, go down a t, no t. And then what's the derivative of just 17? Nothing. Okay, so there's the derivative. Now put a 3 into that. Okay, when does this object reach max height? So you should understand this is a parabola. What do you know about this parabola? It's -4. So what do I know? It's a projectile like this. Negative parabola. So where does it hit the max? Right here. And if I had a tangent line, what would it look like? A tangent line would look like that. What do you know about that line? The slope is what on that line? 0. It's a flat line. There's no slope. So what am I going to do now? I'm going to make this equation equal 0. The slope equation, the velocity equation, that's what this is, the same thing. So at 10 seconds, it gets a max. What is this height? So at 10 seconds, what's the height? Where should you plug that into? Original, because it's the H. This is the H prime. Don't plug it in there. H original, plug in 10. Sorry, I didn't give you units, so we were pretending that I wrote meters on that question. Okay, I'm going to tell you what I always find on this test. I find this part super easy. I find, I would say, these definitions should be easy because if you know how to do all three of them, it's just memorizing the process and I'm not changing anything on the test except for the numbers, right? So those should be easy. It's basically memorizing the process, making sure polynomials get expanded, radicals, conjugates, and then fractions, common denominator. So where do I see people lose the most points? These ones. The analyzing ones. That's where people get challenged the most, okay? So that's where I'd focus your studying on, getting those harder, I would call them harder limits. Those would be the most challenging part of the test. So